So I'm back to practice some u sub with integrals involving u, and I realized I had a typo on this problem. I meant this problem here to piggyback off of this problem that we ended with in the last video, but I put an x in the denominator. I would have to have an x cubed, right? Because I see the derivative of, I'm going to let the exponent be u, okay? I'm always, when I'm working with these exponential functions, so that I get the integral of e to the u, which is e to the u. Okay, so I always let u be the power to which e is being raised. And I saw a few minutes ago that du dx, right, when I went down to the bottom of the page and I took the derivative of this function by bringing it upstairs, right? Dropping the power, decreasing it by 1, and I got this. So I had to make sure that for this problem's going to work, I had to make sure my denominator contained the derivative of u, right? So that I can get that x cubed to cancel. So solving for dx here is just a little bit more complicated. Like, let's think in terms of cross multiplying. So I get negative 2 dx. This is not quite as simple as it usually is. Equals x cubed du. So x cubed du. And then I want to solve for dx, which means I divide both sides by negative 2. Okay, so what I end up getting here is I can replace dx with x cubed. So I'm writing it right over the top of dx because I'm replacing it. X cubed du over negative 2. Let me put that in parentheses so it doesn't look like I'm subtracting 2 from that x cubed. All right. Because I have the x cubed, that's why I had to change this so that my problem could actually be a problem that I can solve. X cubes cancel. This comes out in front. And then what I'm left with, I'll put my work down here. The negative 1/2 comes out in front. And I'm left with what I want to be left with, which is just e to the u, the integral of e to the u du. Okay, and the beautiful thing about the integral of e to the u du is that the answer is e to the u plus c. Okay, and then I go and I replace u with what it was equal to. And let me stress again, the exponent never changes from the beginning of the problem to the final answer, right? Whether I was taking the derivative or whether this exact function was involved in an antiderivative, right? So look at these two problems here and here. Right here, I was taking the derivative and this was the exponent. Exponent stays the same, right? Down here, I was taking the antiderivative where this was the exponent. And again, same exponent ends up in the final answer. All right, so pause the video and let me suggest you try this problem here on your own. Okay, du dx equals 7x. Good thing, those x's will cancel, right? Dx is going to get replaced by du over 7x. All right, so I'm going to get this, e to the u, right? Dx is replaced with du over 7x. X's cancel. I should say divide to 1. You're not supposed to say cancel anymore. Oops, I'm sorry. Then that 7 in the denominator comes out in front. 1/7 e to the u du. All right, my favorite problem ever, because the answer to the integral of e to the u du is e to the u plus c. Okay, so I'm going to jump right to replacing u with its equal, which was the 7x. And again, let me stress, the exponent never changes. Plus c. And then the last few problems on here involve a base other than e. Okay, but again, we have a formula for that. Okay, so this is just a very simple problem. And on your formula sheet, it says that the derivative, if the base is anything other than e, we need to write for the derivative times the natural log of 5. Now, of course, for e, it's still the natural log of e that is there when you take the derivative, but we know the natural log of e is 1. Okay, so if this is the derivative, then what's the antiderivative? What is the reverse of this? Okay, and that would be 5 to the x divided by natural log of 5. Okay, so I don't think I did any problems like this last one in class, but I'm hoping that you can take what we know about taking the derivative of this, and also if something's being raised to a function of x, we have to take the derivative of the function of x and multiply it by the base to the power. Okay, so I hope you can put all those pieces together. Okay, and try this last one, which in any order, does not matter the order you put it in. I need the 7 for the derivative of the function. Then I have 5 to the same power. And then I have times, it's not a bad idea to put these things in parentheses so we don't get confused. And then times the natural log of 5. Okay, so I'm going to put more emphasis on e than I am on other bases, but these would still be fair game. Simple problems involving other bases would still be fair game on the test or quiz. So again, thanks for taking the time to watch and read.